Now we will do the 10th sum. A light of a wavelength 500 nanometer is incident on a sensitive plate of photoelectric work function 1.235 electron volt. The kinetic energy of the photoelectrons emitted is dash. So what are the given quantities? First I will summarize. So the incident wavelength is equal to 500 nanometer. So this is equal to 500 into 10 to the power of minus 9 meter, or this is 5 multiplied by 10 to the power of minus 7 meter. Okay. Now the incident energy is equal to hc by lambda. As usual, h is the Planck's constant, c is the velocity of light in vacuum, and lambda is the incident wavelength. Now this expression is hc by lambda in unit called joule, which is a SI unit. Here itself, if you want, divide this by the electronic charge so that the unit will be electron volt. Otherwise, you convert the work function from electron volt to joule. Final answer should be in electron volt only. Anyway, you can convert. Both are almost the same number of steps. So first I am going to substitute the SI units. Okay. So h is equal to what? 6.6 into 10 to the power of minus 34 joule second into velocity of light is 3 into 10 power 8 meters per second divided by 5 into 10 power minus 7 meter. So energy E is now equal to 6.6. Without calculator also we can multiply. See here, 6 3s are how much? 18. Then 0.6 into 3 is how much? 1.8. So 18 plus 1.8 must be 19.8. So this is a numerator is 19.8 into 10 power minus 34 into 10 power. Okay. This minus 7 will go up as what? Plus 7. So 8 plus 7 is 15. Whole divided by 5. So 19.8 can be divided by 5. Okay, by 5 if you divide means 5 3s are 15. So this will be divisible by 5 means no. So the remainder is coming. So I will divide this around 3.96 it will come. Okay. So 3.96 is coming into. Now 10 power minus 34 into 10 power plus 15 is 10 power minus 19. So this is 10 power minus 19. I have told you in the previous numericals also, 10 power minus 19 is the standard value. So whenever one electron volt is converted into joule, this 10 power minus 19 will be cancelling. That is why. Okay. So we will take this energy incident is equal to 3.96 into 10 power minus 19 joule. Then what is the work function, students? What is the work function given here? It is 1.235. So work function phi naught is given in electron volt. So this is 1.235 electron volt. This is equal to 1.235 multiplied by electronic charge. That is 1.6 into 10 to the power of minus 19. When you multiply means electron volt will be converted into SI unit joule. So what is the product of 1.235 and 1.6 with calculator if you do means it is 1.976. So this is equal to 1.976 into 10 to the power of minus 19 joule. So both are coming in the same unit, that is joule. Now the general equation. What is the photoelectric equation? Einstein's photoelectric equation. The incident energy must be equal to the sum of work function and kinetic energy. So I will write. So this is now equal to what? Incident energy is what? E. So that is equal to work function phi naught plus kinetic energy is what? E kinetic. I will use the symbol E kinetic for kinetic energy. What is asked in the question is the kinetic energy of the photoelectrons only is asked. Already E we have found here. Work function also is given here. So what is kinetic energy must be equal to E minus phi naught, is it not? Therefore, okay, E kinetic must be equal to this energy E minus work function phi naught. So this is now equal to what? 3.96 into 10 power minus 19. This also of the order of 10 power minus 19. So I will write this is equal to 3.96 into 10 power minus 19 minus 1.976 into 10 to the power of minus 19. So the unit is joule. So this is equal to what? 3.96 minus 1.976 into 10 to the power of minus 19 joule. So it is still in joule only. So when you subtract 3.96 minus 1 point, the calculated value, okay? So you can use the calculator and find out. So this is equal to 1.984, okay? This is equal to 1.984 multiplied by 10 to the power of minus 19 joule. But the answer is expressed in joule, but the options are given in electron volt. Okay, students, actually this is the kinetic energy in SI unit, okay? But we have to convert this. We have to convert this in what? Electron volt. So 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Now the reverse of that, joule to electron volt. Joule to electron volt means, so this is also now equal to, okay, kinetic energy is equal to 1.984 into 10 to the power of minus 19 divided by electronic charge 1.6 into 10 to the power of minus 19. So that now the joule is converted into electron volt. Understand? Joule can be converted into electron volt by dividing by the electronic charge. So the power 10 power minus 19 is getting cancelled. So if you cancel this and calculate, this is coming as 1.24 electron volt. Therefore, the kinetic energy of the emitted photoelectron in electron volt, it is 1.24 electron volt. So we have calculated already in joule. It is also now expressed in electron volt. Okay, students, both you must remember. See, attending the problems in photoelectric effect is not so easy. Concept may be easy, but this joule to electron volt or electron volt to joule conversion always you will have to keep in mind. In the same system of unit only you have to continue the calculation. Okay, students, now I have got the answer. Kinetic energy is 1.24 electron volt. So which of these 4 options is correct now? Option C is correct, is it not? So option C is the correct answer. So this is how you have to verify the correct answer. Have you understood?